Hello everyone, I am Shoykot Mondal, PhD student from Software Research Lab, University of Saskatchewan, Canada. In this opportunity, I would like to present our paper entitled Early Detection and Guidelines to Improve Unanswered Questions on Stack Overflow. This is a collaborative study with Khaled Saifullah, Abhijit Bhattacharjee and Masood Rahman. This study was conducted under the supervision of Professor Dr. Chanchal Roy. Nowadays, all the developers are connected through Stack Overflow. Stack Overflow is one of the largest and most popular question answering sites for programming problems and solution. It is the most popular site among 174 sites of Stack Exchange with 19 million questions, 29 million answers, 12 million users, 9.8 million visits per day and 8.6 thousand questions posted per day. It is the 53rd most visited site in the world and 49th in the USA. Moreover, Stack Overflow often get indexed top by Google search for programming related queries. However, despite having such popularity, large and engaged community, a huge number of questions are not answered at all. Up to 29% of the questions remain unanswered in the year 2018. Unfortunately, this percentage has been increasing gradually over the years. Unanswered questions kill the developer's time, impede the normal development progress, and hurt the quality or purpose of this community-oriented knowledge base. In this study, we thus attempt to detect unanswered questions during their submission and guide the question submitters to improve their questions. First, let me show the overall methodology of our study. We collect 4.8 million questions related to 4 popular programming languages such as Java, C#, JavaScript and Python that were posted on or before 2017. We then separate the answered and unanswered questions and extract 8 features such as text readability, topic response ratio, topic entropy from both unanswered and answered questions. We conduct a comparative analysis between the attributes of those two categories. We then manually analyze 400 questions to investigate the qualitative difference between unanswered and answered questions. In particular, we attempt to determine whether the qualitative findings agree with the quantitative findings or not. We build 4 machine learning models to predict whether Stack Overflow questions might be answered or not. Finally, we analyze the results of our models and also compared with the state of the art models. In particular, we attempt to answer 3 research questions in this study. First, how do the unanswered questions differ from the answered questions in terms of their text and their submitters' activities? Second, how do the unanswered and answered questions differ qualitatively? Do the qualitative findings agree with the quantitative findings? And third, can we predict the unanswered questions of Stack Overflow during their submission? To answer first research questions, we contrast between the unanswered and answered questions using 8 metrics that capture different aspects of a question. The metrics are text readability, topic response ratio, topic entropy, user reputation, and so on. First, text readability. You know, readability of a text document depends on the complexity of its vocabulary, syntax and the presentation styles such as line lengths, word lengths, sentence lengths, syllable counts. We extract the title and textual description from the body of each question to measure its text readability. We discard the code segments and extract traces. We compute 5 popular readability metrics such as automated reading index, smoke grade, gunning fox index, readability index. These metrics are widely used to estimate the comprehension difficulty of English language text. First, we calculate the individual score, that means the grade level, for each of the 5 metrics, and then determine the average readability of each question's text. The lower the grade level, the easier the text is to read, and vice versa. As shown in the box plot, we find a significant difference in the text readability between unanswered and answered questions. Answered questions have higher text readability than that of the unanswered questions. We also address the data imbalance issue during our comparative analysis. Since the number of answered questions is higher than that of the unanswered questions in our dataset, we randomly undersample the answered questions to balance the dataset. Then we compare the readability scores between unanswered and answered questions. Again, with the sample data, interestingly, we can able to reproduce the same findings as above. We also perform a statistical significant test using Mann-Whitney Wilcoxon and Clips delta and found a statistically significant difference with a small effect size. That is, the readability of answered question is significantly higher than that of the unanswered questions regardless of the programming language. In Stack Overflow, questions often might not receive answer due to their topical difficulty. Questions related to certain topics such as software libraries, platforms, IDE usually get less attention than others. We first examine which topics are more likely to receive answers and which are not. In Stack Overflow, tags often capture the topics of a submitted question. We first calculate the answering ratio of each topic dividing the number of answered questions by total questions associated with each topic. Since each question can have multiple topics, we then measure the topic response ratio of each question. We sum all the topics response ratio and divided by the number of topics. See the box plot. The topic response ratio of unanswered questions is lower than that of the answered questions. It indicates that the topics of unanswered questions are of little interest to the Stack Overflow user community. It is also possible that there are not sufficient experts to answer the topics discussed in the unanswered questions. We also found this difference as statistically significant with medium effect size. That is, topic response ratio of answered question is significantly higher than that of the unanswered questions. Then topic entropy. Single tags, for example Java, assigned to a question often fail to explain the topics or subject matter of the question. On the contrary, multiple tags attached to a question could help the users better understand the topics and thus help them find the questions of their interest. We analyze the ambiguity of question topics using topic entropy and attempt to determine whether the unanswered questions use more ambiguous topics than those of the answered questions. We see that topic entropy of answered questions is significantly lower than the unanswered questions. Such a result indicates that the unanswered questions are more ambiguous than the answered questions, which possibly left them with no answers. We use metric entropy and average terms entropy to estimate the randomness of terms used in the textual part of the unanswered and answered questions. Metric entropy is the Shannon entropy divided by the character length of the question's text. It represents the randomness of the terms against a question. Average terms entropy also estimates the randomness of each term for the question's text. However, in this case, the entropy of each term is calculated against all the questions of a Stack Overflow. As shown in table, we find a relatively lower metric and average terms entropy for the unanswered questions than that of the answered questions. That is, the unanswered questions use more uncommon terms in the text than the answered questions do. According to our analysis, we found the differences are statistically significant. However, the effect size is either small or negligible. Then the text code ratio. The ratio between text and code of a question is often considered as an important dimension of question quality. Large code segments with little explanation might make a question hard to comprehend. We extract the code segment and text from the body of a question. We then calculate the text code ratio by dividing the character length of the text with the length of the code segment. When the code segment is absent from a question, we assign a large number as the text code ratio. According to our analysis, the text code ratio of the unanswered question is lower than that of the answered questions. That is, insufficient explanation of the code segment could be a potential factor that might explain why the questions remain unanswered. We also measure whether the difference is statistically significant or not. From the Mann-Whitney-Wilcoxon text, we find a significant p-value. However, the effect size from the Cliffs delta test was found negligible. Then the reputation system of a Stack Overflow is designed to incentivize contributions and to allow assessment from the users. Existing study shows that a question submitted by a user with a higher reputation has a higher possibility of getting answers. We thus consider this user's reputation as a distinctive feature of a Stack Overflow courses. We calculate the reputation of users during their question submission using a standard equation provided by the Stack Overflow. According to our analysis, the reputation of the authors of unanswered questions is lower than that of the answered questions. It confirms that the high reputation score increases the chance of getting answers. Using the Mann-Whitney-Wilcoxon test, we find a significant p-value, although the effect size is small. The past question answering history of a user might provide useful information as to whether a question submitted by the user will be answered or not. Thus, we investigate a user's question answering statistics. In particular, we measure the percentage of answered question asked by users during the new question submission. According to our analysis, a user with a higher percentage of receiving answers in the past has a higher chance of receiving answer in the future. In the table, the authors of the answered question received answers about 71% of their submitted questions in the past. On the contrary, the same percentage is about 60%. The difference is statistically significant with a small effect size. In research question 2, we find the agreement between quantitative and qualitative findings. We first find the top 10 topics that are unanswered and another top 10 topics that are frequently answered. Finally, we randomly choose 20 questions for each of the 20 topics. That means 400 questions for manual analysis. Two of the authors conduct manual analysis to see the different quality aspects of answered and unanswered questions. We first examine the randomly sampled questions with no particular viewpoint in mind. We then discuss together to share our understanding and set a few dimensions to proceed our manual analysis. The authors rank them with 4 major quality aspects from 0 to 5. Aspects are problem description and code explanation, topic assignment, question formatting, appropriateness of the code segments included with questions. The figure shows the results of our manual analysis. For each of the 4 aspects, the average ranking for unanswered questions is lower than that of the answered questions. For example, the appropriateness of the code segment is 2.7. For unanswered questions, such rank is 3.63 for the answered questions. We use 4 algorithms for building prediction models. They are decision trees, random forest, k nearest neighbors, and artificial neural networks. We choose those algorithms for 2 reasons. First, they are capable of building reliable models, even when the relationship between the predictors and class is nonlinear or complex. Second, these algorithms are widely used in the relevant studies. We evaluate our models using 4 appropriate performance metrics: precision, recall, F1 score, and classification accuracy. We use a grid search algorithm, namely grid search CB, for the scikit-learn library to select best model configuration. We keep the training and testing datasets separate. We use the attributes of the questions submitted on Stack Overflow in the year 2016 or earlier for the training and questions submitted in the year 2017 for the testing purpose. We have several time-dependent features, for example, user reputation. Thus, we make sure that we predict the unseen questions based on the past questions. To predict unanswered questions, we built 4 machine learning models. We see that all the 4 models can predict the question classes with 61 to 79% accuracy. The random forest performs the best among 4 models with precision about 78% and recall 81%. Decision tree is found as the second best with precision about 73% and recalls 67%, followed by KN and ANN. On clear distinction can be drawn from the results that individual feature processing algorithms random such as random forest and decision trees are comparatively better suited for our dataset than the collective feature processing algorithms such as ANN and KNN. We then rank our features using extra tree classifier, an inbuilt class of scikit-learn to rank features as shown in figure. Topic response ratio has the highest classification strength. It indicates that selection of appropriate tags during question submission at a Stack Overflow is important. User reputation is the second most effective feature. That is, the trusted users by the Stack Overflow community are more likely to get answers in response to their questions. The next two important features are metric entropy and text readability. Our proposed models able to predict questions about 60 to 80% of the time correctly. However, we are interested to compare our models with the baseline models. Thus, we choose two state-of-the-art studies by Shah et al. And Califato et al. Here, figure shows the comparative results between the proposed models and the baseline models. The performance of the models by Califato et al. Is found comparatively poor than that of the others. Their accuracy and precision are found in the range of 50 to 52%. The model from Shah et al. Is performed comparatively better than the Califato et al. The overall accuracy of the models by Shah et al. Is found 53 to 55%. However, the proposed machine learning models outperform both the baseline models. The precision of the proposed model is about 6 to 25% higher than the models by Shah et al. And about 9 to 27% higher than that of the Califato by Califato et al. To test our models to confirm the generalizability of their performance and strength of the features, we select questions from two different programming languages that are not used to train our models. The languages are C++ and Go. Then we also see that our models performs reasonably well. Our model, in that case, our model can predict the unanswered questions with a maximum of about 66% precision and 67% accuracy. Such findings confirm the general acceptance of our features and models in predicting the unanswered questions. Yeah, now we report the key findings and guidelines. First, proper formatting of the description in a question is essential. In particular, the different elements are recommended to place inside the appropriate HTML tags to improve their visibility and readability. Second, if a question describes a code-related issue, it should include an example code segment to support the problem statement. Third, a clear description might prompt the experts users to answer a question. Fourth, several topics are more likely to be unanswered in Stack Overflow. According to our analysis, top unanswered topics are primarily related to programming IDs, libraries, and frameworks. So, users should avoid submitting off-topic questions and carefully select the tags for their questions. Fifth, some users often discuss multiple issues in a single question, which is not recommended by the community members. Sixth, we find several questions received working solution in their comment threads. We also find several other causes that might leave the questions unanswered. First, several questions remain unanswered since they discuss outdated technology. Second, many unanswered questions are found with misleading titles. Third, users sometimes requested suggestions instead of discussing problems clearly and asking particular solutions. Fourth, some questions are perceived as duplicates to the other questions. Yeah, and that is all I have for this presentation. I sincerely appreciate your attention. Thank you all. Feel free to ask any questions.